It is no secret that as technology advances, so do the problems that arise within it. In the case of the internet, there are so many vulnerabilities that are constantly being exploited and taken advantage of, such as those of the Transmission Control Protocol, or TCP. At this point, you may be thinking, what in the world does that mean? For starters, a protocol is an accepted set of rules for how something operates. Here, the protocol determines how information is sent across the internet completely and reliably. When we send large messages over the internet, they are broken down in a package which are smaller chunks of information that form bigger pictures. By doing this, information can be sent faster and more reliably than if one message was being sent all at once. However, sending information in packets brings up the issue of not breaking the message into smaller chunks, but rebuilding it when the message arrives. This is exactly what the TCP was made for. As the chunks form packets, this protocol numbers the packets so that they may be assembled in correct order upon delivery to the receiver. As you can see, this is a very essential part of the internet, as you do not want to be reading a message out of order or looking at a jumbled up picture. In order for the transmission control protocol to work, there is what we call SYN segments that establish a connection between a client, the computer requesting information, and the server, the computer supplying that information. When a client wishes to interact with a server, it first sends a SYN, short for synchronized, message to link up with the server. Then the server replies with an acknowledgement, or ACK message, to confirm that the connection going that way, but then it also sends a SYN message back as well. Once the client sends an ACK message back, the connection has been established and they are ready to communicate. It is important to note that, as indicated by the TCP, the server is required to respond and cannot proceed until the connection is established. With that being said, there are both positive and negatives to this protocol. Beginning with the upside, the protocol is very obviously useful in that it assures the connection between two computers and reliably sends the information. This is crucial to the structure of the internet because nobody wants to use it if every other message is lost. On the other side, the nature of this protocol allows it to be exploited by hackers. One way hackers do this is through a process called SYN flooding. In this situation, hackers send a large amount of SYN messages that appear to be coming from different computers, though they are not. The computers from which the messages are called are bots, and many computers are tapped into and they create a botnet, which hackers can utilize. Back to the main point, as a result of these various SYN messages, the server sends back SYN ACK messages. Recall that the server is required by the protocol to answer and wait for a response. At this point, the hackers prevent an ACK message from going back to the server from the bot so that the server is left waiting for acknowledgement. That causes the server to hold open communication lines, taking up part of its capacity, waiting for the messages that will never receive. When a large amount of these bots initiate the sequence, the server can be rendered useless when its capacity is taken up by open connection lines, effectively causing a denial of service. This is exactly what happened just recently to the DIN service provider, but on a worldwide level. DIN is responsible for many companies such as Amazon, Etsy, Shopify, Twitter, and New York Times, and they have servers located all throughout the globe. By mainly using SYN floods, a hacker group was able to effectively cripple DIN's system by launching synchronized attacks on more than 20 different domain servers. The ramifications of such an attack include a huge loss of business, as some websites could not be accessed. The fact that a hacker organization could control such a large part of the economy, such as e-commerce, is a major issue. At this point in time, there are some measures to counteract these types of attacks, but with a recent attack on DIN, it is apparent that these preventative measures can still be surpassed. Perhaps rather than dwelling on the negatives of this event, we can use it to inform us as how to prevent them in the future. In the near future, the Internet Engineering Task Force should consider reworking the TCP in order to better ensure that the attacks such as this never happen again.